Hi, this is Felix. Today we are going to discuss the electrostatic potential at a point due to an electric dipole. So now first of all we have to consider there are 2 points A and B, and here we are considering negative charge and positive charge respectively, and both charges are separated at a distance of 2A. And here we have considered there is a midpoint O. From its midpoint each charge placed at a distance. As we know that always the dipole moment will act a negative charge to the positive charge, and here this will be denoted in terms of P vector. Now from this midpoint at r distance we have to consider an external point P. Now from positive charge the external point placed at r1 distance, from negative charge the external point placed at r2 distance. Now we are trying to calculate the potential with respect to positive charge and with respect to the negative charge. Okay, next we have to calculate the total potential developed at P with respect to the dipole. Okay, so first step we have to calculate the potential at P due to the positive charge. Due to positive charge, what is the potential developed at P? As we know that V1 which is equal to 1 divided by 4 pi epsilon naught Q divided by R1, and due to the negative charge at P, what is the potential is developed? V2 which is equal to minus 1 divided by 4 pi epsilon naught Q divided by R2. Now why here is a negative and here is a positive? Because if you choose the positive charge the potential is positive. If you consider a negative charge the potential also is negative. That's why here is a minus. Next we have to calculate the total potential at P. So how to calculate total potential? We have to add these two values. So V1 plus V2, and in this two term Q divided by 4 pi epsilon naught is common, so take it outside. The remaining is nothing but 1 divided by R1 minus 1 divided by R2. By applying cosine law for triangle BOP, for this BOP in this triangle we have to use cosine law to find R1 and R2 value. Okay, so here c square which is equal to a square plus b square minus 2ab cos alpha, this is the general form, and here instead of c we have to substitute R1, instead of a we have to substitute R, instead of b a, and instead of alpha we have to substitute theta. Then the above expression will be rewritten like this. Okay, R1 square which is equal to R square plus a square minus 2RA cos theta. Next, in this term we have to take R square as common value. From this R square we have to take it outside R square, then the remaining value is 1, so we have to substitute here, and here there won't be any R squared, so that we have to return in terms of denominator, and here 1 R is available in numerator, so it is taken outside, and the remaining we don't have, so that we have to divide it by R. So the above expression will be simplified like this. Now R is very greater than A, so that A square divided by R square is neglected. So the above term, this term will be neglected. Then we will have R1 square which is equal to R squared 1 minus 2A cos theta divided by R you will get. And next we have to take square root on both sides. If you take square root on both sides, here R1, here R, and here 1 minus 2A cos theta divided by R power 1 by 2. And next we have to take the reciprocal of this. Okay, because we must calculate the value of 1 divided by R1, not R1 alone. 1 divided by R1 we need to calculate, for which we have to take a reciprocal. So 1 divided by R1 which is equal to 1 by R, 1 minus 2A cos theta divided by R power minus 1 by 2. Because reciprocal, so that minus 1 by 2. Next, use binomial theorem and retain the terms up to first order. So we have to simplify this term alone. For this term alone we have to use the binomial theorem and simplify. You will get 1 divided by r1, which is equal to 1 by r within a bracket 1 plus a cos theta divided by r, and this is equation number 2. And next here similarly apply cosine law for triangle. So another one triangle will have, that is nothing but AOP. Okay, similarly we have to calculate, and here r2 square, which is equal to r square plus a square minus 2ra into cos theta. So here theta is nothing but 180 degree. So 180 minus theta. So this is the theta value. Okay, so now we see the diagram. Okay, so second angle is nothing but 180 minus theta. So we have to substitute this value here. Right. Now cos 180 minus theta, which is equal to minus cos theta, so that this value we have to substitute. So minus into minus it become plus. So r2 square, which is equal to r square plus a square plus 2ra cos theta. Okay, now the same way we have to do it. Okay, what is that? We have to take the r square separately, then 1 plus a square divided by r square plus 2a cos theta divided by r. Okay, next we will have r is very greater than a, so that a square divided by r square is neglected. Okay, now so which means that this term will be neglected. Then r2 square, which is equal to r square 1 plus 2a cos theta divided by r. Next what we have to do it, we have to take square root on both sides. Then r2, which is equal to r 1 plus 2a cos theta divided by r, power 1 by 2. That square root will be written in terms of power 1 by 2. Now we need to calculate 1 divided by r2 value, so that we have to take reciprocal. 1 divided by r2, which is equal to 1 divided by r, then 1 plus 2a cos theta divided by r, power minus of. Okay, now for this term alone we have to use binomial theorem. Okay, use binomial theorem and retain the term, retain the terms up to first order. Okay, so which means 1 divided by r2, which is equal to 1 divided by r, then 1 minus a cos theta divided by r, and this is equation number 3. Substitute equation 2 and 3 in equation number 1. So v, which is equal to q divided by 4 pi epsilon naught. Now 1 divided by r1 value, what is that? 1 divided by r1 value, 1 divided by r 1 plus a cos theta divided by r. Okay, minus 1 divided by r2 value, 1 divided by r 1 minus a cos theta divided by r. Okay, now we have to simplify, because 1 divided by r1, here also 1 divided by r1, so we can take it outside. So q divided by 4 pi epsilon naught into r. What about the remaining 1 plus a cos theta divided by r? Then this minus we have to multiply inside, so minus 1, minus into minus it becomes plus. Then here a cos theta divided by r, and here 1 and minus 1 will be get cancelled. So now here q divided by 4 pi epsilon naught into r. So here a cos theta divided by r, a cos theta divided by r. When you add, you will get 2a cos theta divided by r. So this is nothing but capital V. Now as we know that P which is equal to, okay, P which is equal to 2QA, and now substitute in this above equation 2AQ. Instead of this we have to substitute P. So P cos theta divided by 4 pi epsilon naught r into r squared and B. So this is nothing but the total potential which is developed in the external point due to the dipole. Some special cases. Case number 1. If theta which is equal to 0, which means the external point lies on the axial line, okay, or we can say along the dipole, along the direction of the dipole moment. So if theta which is equal to 0, cos 0 degree which is equal to 1, and substitute in final equation, you will get V which is equal to 1 divided by 4 pi epsilon naught P divided by r squared. Next, case 2. So now if theta which is equal to 180 degree, so what is that 180 degree? Opposite to the dipole moment. If the external point is considered opposite to the dipole moment, which means cos 180 degree which is equal to minus 1, then the total potential V which is equal to minus 1 divided by 4 pi epsilon naught P divided by r square. And next we have to see case number 3. Case number 3. If theta which is equal to 90 degree, which means the external point is considered in the perpendicular to the dipole, okay, perpendicular to the dipole. So which means cos 90 degree which is equal to 0. Now V which is equal to, when you substitute the 0 value here, 0 into anything, the value it becomes 0. So the total potential it becomes 0. So now with respect to the position of an external point, so the potential will be varying. So here V which is equal to 1 divided by 4 pi epsilon naught P divided by r squared when the external point along the axis of the dipole moment, and if the external point is opposite to the dipole moment, the direction of the dipole moment, then you will get minus 1 divided by 4 pi epsilon naught P divided by r squared. Suppose if you consider perpendicular to that, then the potential it becomes 0. Thank you.